Hey all, it's Giles here, and welcome to the 8th lesson of Cambridge International Education IGCSE Physics P2 Thermal Physics. And as you can see, today's lesson is on evaporation. So our two learning objectives for today: describe in detail the process of cooling by evaporation and compare it to boiling. And the second one is you recall methods by which to increase the rate of evaporation. So first of all, boiling is the process of a liquid turning into a gas, and you probably already know that happens at 100 degrees Celsius. Evaporation occurs when particles at the top of the liquid gain enough energy to break free of the liquid. And it can happen at temperatures much lower than 100 degrees Celsius. That is why if you leave, say, a glass of water on a windowsill, come back later, there'll be less. And that is because some of it's evaporating. Now, the room hasn't reached 100 degrees Celsius, but it is hot enough to make some water evaporate. So a couple of quick questions here. Will the particles at the top, which evaporate, have the most or least energy? Well, to answer that one, they're the ones that are going to escape, so they're going to have the most energy. And then the second part says, when these particles leave the liquid, what will happen to the average energy of the remaining liquid? Explain the reason for your answer. So here, I'm just going to simplify it. What is the mean energy of the particles? Well, there's 4 particles. 4 add 6 is 10. 5 add 10 is 25. Divided by 4, and you've got 6.25 joules of energy each. Now, we said earlier, the ones with the most energy are at the top, and they're the ones that evaporate. So let's say we lose this one particle. So after the particles at the top with the most energy has left, the mean amount of energy has decreased to 5 joules. So the amount of energy has reduced because we've lost the most energetic particles. Okay. So to answer this question, the most energetic particles have left, so the remaining particles have less energy. Now, evaporation happens because energetic water molecules at the surface of the water escape into the surroundings. The total volume of liquid water decreases because some of it's evaporated, some of it's going to go into the air. It also has a cooling effect. So liquid that is evaporating experiences a cooling effect. This is due to the escape of more energetic particles, leaving behind the less energetic particles. As a result, the average internal energy and therefore temperature of the liquid decreases, and it also takes heat away from the body, which makes the body decrease if we're talking about something like sweating. So a moist towel is often placed on a patient's head when they've got a temperature. This works because of the cooling effect when liquid undergoes evaporation. Energy from the patient's forehead is transferred to the evaporating liquid. Okay, so we'll do a little comparison of evaporation to boiling. So evaporation happens at all temperatures, whereas boiling occurs only at the boiling point. So like I said, if it's water, it's 100 degrees Celsius. Evaporation happens only at the surface. Boiling happens throughout the liquid. Evaporation, it's very slow, whereas boiling is much quicker. You don't get any bubbles of evaporation, but when something boils, you start to get bubbles. And the liquid cools down, whereas boiling, and this goes back to our change of state we looked at in the previous lesson, the temperature remains constant whilst the liquid is boiling. One similarity, both involve the change of a liquid to a gas. So, a couple of questions on what we've talked about here. So, question 1, water in a beaker is heated in a lab. Which statement about boiling and evaporation of the water is correct? Boiling and evaporation both occur at any temperature. No, boiling has a fixed point. Boiling only occurs at the surface. No, it happens throughout the liquid. Evaporation only occurs at one temperature. No, it happens at a range of temperatures. So evaporation only occurs at the water surface is correct. Okay. And I'll just give you a minute to have a go at the rest. Then I'll put the answers on. So C, B, A, and A again. Okay, so that is the first learning objective, almost complete. Describe in detail the process of cooling by evaporation and compare it to boiling. Now, we're going to look at ways of speeding up the process of evaporation. So here I've got some sanitizer. It's preferably an alcohol-based one. And you can try this yourself. If you spray it onto the back of your hand and then blow on it, you will feel your hand gets a lot cooler. And that's because sanitizer evaporates a lot more easily than, say, water. And when you blow on it, you speed up the rate of evaporation, which cools your hand down. So there's four main ways to increase evaporation. You increase the temperature, increase the dryness of the air, reduce the humidity. So I'm here in Malaysia. Evaporation is going to happen a lot slower than, say, somewhere like Dubai, where it's a lot drier. Let air flow over the liquid, so let some sort of breeze or draft over, and increase the exposed surface area. Okay, so we've gone into a little bit more detail about some of these. The higher the temperature of the water, the higher the rate of evaporation. So wet clothes dry faster on a warm day because more of the water molecules have enough energy to escape from the surface. Likewise, if we keep our clothes out, the larger the surface area of the water, the higher the rate of evaporation. So clothes dry faster when you spread them out. More molecules are closer to the surface and will be able to escape. You could try it yourself by putting your clothes out on a line, put one out quite spread out like this, and maybe have another one sort of all crumpled together. The one crumpled together is less likely to dry. And adding a draft. So the greater the draft, the higher the rate of evaporation. The wind blows away evaporated water molecules, water vapor, from the surface of the water. This prevents them from returning to the liquid. Okay, so a couple of very quick questions for you. Give you a few seconds. Okay, so which is the only state of matter which can evaporate? It's the liquid. If sweat evaporates off your body, what effect will it have on your temperature? It'll decrease it. In which of these cups will a coffee cool down fastest? Cup 2, because it's got a wider top, so a larger surface area exposed. And explain why blowing on soup can help it cool down quicker. This creates a flow of air over the liquid or soup, which increases the rate of evaporation, reducing the average energy of the soup particles left behind. Now I'll have a look at a couple of the paper 2 multiple choice questions. Okay. So a cup contains hot liquid. Some of the liquid evaporates as it cools. What happens to the mass of and to the weight of the liquid in the cup as it cools down? So we've got different options. We'll start from the top. The mass is going to decrease, and so is the weight. So it's going to be A. Because if you lose some mass, obviously weight is mass times gravitational field strength. They're both going to go down. So it's A. The diagram shows a beaker of water. 4 molecules are labeled. The relative amount of energy of each molecule is shown. Which molecule is most likely to escape from the liquid? It's going to be the one near the top with the most energy, which is A. Okay. Question 3. Which factor increased the rate of evaporation? Increasing its temperature? Yes. Increasing the surface area? Yes. The depth. Now, regardless of whether you've got a shallow cup or a deep cup, it's going to be the same rate of evaporation. So that is not a factor. So the answer is B. Question 4. A swimmer feels cold after leaving warm water on a warm, windy day. Why does she feel cold even though the air is warm? So we'll start from the top. The less energetic water molecules on her skin escape quickly. It's the most energetic, so it's not that. The more energetic water molecules on her skin do not escape. Well, they do, so it's not that. The water on her skin does not evaporate quickly enough to keep her warm. It's not that. It's the water on her skin evaporates quickly and cools her skin because she's got all the conditions she needs. It's warm and it's windy. So that's some of the conditions she needs for evaporation. So the answer is D. Okay, and the last question. The diagram shows 4 open dishes. Each dish contains water at the same temperature. The dishes are different shapes and a draft blows over 2 of them. From which container does the water evaporate at the greatest rate? So you want the draft, so it's going to be either A or B, and you want one with the largest surface area exposed, which is A. Okay, so thank you very much, everyone, for listening. The next lesson is going to be on thermal conduction. I will post a link in the description below. Thank you very much, and see you in the next video.